A very warm welcome to you all, my KCET champions. How are you all? I hope you all are doing great. This is your Ekta Ma'am here. So my dear students, this is one of the most requested video by you all. All the important name reaction. Yes, for your KCET 2026, all the important name reaction that you need to know before appearing for your KCET exam. Yeah, right? And see, organic chemistry is one of the most difficult portion that is most of the students consider that it is one of the most difficult portion. They are not able to memorize all the reactions and all. But if you complete those reactions, if you learn those reactions, trust me, your marks are not going anywhere. Okay, these are the reactions that are coming in your exam in the last 10 years so frequently that if you do these reactions, your organic chemistry marks are not going anywhere. Okay, so let's start with the reactions without wasting time. Okay, first reaction is your okay, one second. The first reaction is aldol condensation. Now, what is aldol condensation? So, it's a reaction between carbonyl compounds, right? Two carbonyl compounds in presence of a basic medium, acidic medium, depends on that. What products we get? We get beta hydroxyaldehyde or beta hydroxy ketone, and after dehydration, that means after loss of a water molecule, we get alpha beta unsaturated carbonyl compound. What do we get? We get alpha beta unsaturated carbonyl compound. So what you need to learn from this, actually, you just need to now know how to write this compound, this alpha beta unsaturated carbonyl compound. That means, what do you mean by alpha? First of all, alpha means this carbonyl carbon, CO group, right? Adjacent to this carbon, adjacent to this CO group, whatever carbon is attached, that is your alpha carbon. And to this carbon, the number of hydrogens that are attached are called your alpha hydrogens. Okay, so how do they react? Very simple, very easy, whatever is there. So normally a trick you can remember, for example, you write that carbonyl compound like this, right? And the second carbonyl compound I take, let's say I wrote it like this. One second. Okay, we wrote it like this, CH, C double bond O, CH3. Okay, it's like this. So how do you write the product? You just remove this water molecule. If you remove this water molecule, this will be your product. Double bond with this CH and C double bond O, CH3. Now this is your alpha carbon and this is your beta carbon, right? Alpha beta unsaturated, and there is a carbonyl group. Alpha beta unsaturated carbonyl compound. Okay, that is your simple way of writing aldol condensation product, because in exam you don't have the time to write full mechanism and all. Okay, so this is a simple mechanism. You just remove this water molecule and this is your alpha beta unsaturated carbonyl compound. Okay, clear? Okay, next reaction shall we? Yes, the next is carbylamine reaction. So it is a very important reaction that is given by primary amines. Okay, only primary amines give this reaction. And what is that reaction? So primary amines, when they are treated with chloroform and potassium hydroxide or any alkali, chloroform and any alkali, they form isocyanide. They form a compound called isocyanide. Now this isocyanide is really foul smelling. Okay, so it is used as a test to, it is also used as a test to detect the presence of primary amines. Okay, so the test is given by primary amines. What is the test? So when primary amines are treated with chloroform in presence of any alkali, we get a foul smelling substance which is isocyanide. Okay, that is your carbylamine reaction. Simple, clear? Next reaction? Yes. So the next reaction is Cannizzaro reaction. So it is very similar to your aldol condensation, but there is a big difference. That is, in here there is no alpha hydrogens. When no alpha hydrogens are there, carbonyl compound gives Cannizzaro reaction, right? So in aldol condensation we were getting what? Alpha beta unsaturated carbonyl compound, right? Or beta hydroxy carbonyl compound, right? Okay, but here what you will get? You will get two compounds. You will get two products. First is a sodium salt or potassium salt, sodium or potassium salt of carboxylic acid. And second, you will get an alcohol, a primary alcohol to be precise, a primary alcohol. Okay, is this visible to you all? If it is not, I think it is. So I'll try to use a different pen here. One second. Okay, so here this is benzaldehyde. It does not have any alpha hydrogens. Now when this benzaldehyde is treated with concentrated base, now see, in aldol condensation we use a dilute base because obviously there are alpha hydrogens there, so the reaction will happen. But since here there is no alpha hydrogens, for the reaction to happen you need a strong base. Okay, so in presence of a strong base NaOH KOH, we get two compounds. We get a carboxylic acid here and we get a primary alcohol, a carboxylic acid and a primary alcohol. Okay, clear? any aldehyde or any ketone that does not have an alpha hydrogen, they will give Cannizzaro reaction. Okay, next one is Clemmensen reduction. Now Clemmensen reduction is also given by aldehydes and ketones. What is this reaction? So very simple, very easy reaction. Your aldehydes and ketones, when treated with zinc amalgam in presence of HCl, they get converted into what? Alkanes. So it's a reduction. This oxygen group is getting reduced to hydrogens. It is getting reduced, right? Oxygen is getting converted into hydrogens. That is your Clemmensen reduction, right? Clemmensen means you have an aldehyde or a ketone and you treat it with zinc amalgam in HCl and we get an alkane. Okay, we get an alkane. Simple, right? Okay, there's one more reaction which is similar to Clemmensen. Name that reaction. Yes, that is Wolff-Kishner. Next reaction, Etard reaction. So Etard reaction is a reaction that is used for the preparation of benzaldehyde. Okay, so in Etard reaction we use chromial chloride in any organic solvent like carbon disulfide. Okay, in carbon disulfide or CCl4 we also used. Okay, in chromial chloride is used with carbon tetrachloride. Okay, these type of solvent we use. Okay, what happens here? Any toluene we take, toluene, this is toluene, right? Toluene gets converted into benzaldehyde. Okay, toluene gets converted into benzaldehyde. Now the reaction stops here, or one more thing can happen. If we use a different reagent, the reaction will go up to carboxylic acid. Alkyl benzene, from alkyl benzene to you have benzaldehyde and then you will have benzoic acid, but that is a different reaction. That is a reaction with KMNO4. But in Etard reaction you treat any majorly you treat toluenes with chromial chloride in presence of CCl4, you get a benzaldehyde. Okay, that is your Etard reaction, that is used for the preparation of benzaldehyde. Okay, so it is used for the preparation of benzaldehyde. Next reaction. Okay, next reaction. Okay, one more thing. Sometimes somebody will ask ethyl benzene if we use, so the product will not be benzaldehyde. In that case, you will get acetophenone. Okay, in that case, you will get acetophenone, which is a ketone. Okay, okay. Now the next reaction is Finkelstein reaction. So Finkelstein reaction is used for the preparation of iodoalkanes. Okay, majorly iodoalkanes. So you are given any chloro or bromoalkanes, chloro and bromoalkanes, when they are treated with Ki in acetone. When they are treated with Ki in acetone, we get iodoalkanes. That is the reaction. Simple. Finkelstein reaction is used to synthesize iodoalkanes. Okay, now the next reaction, yes, we have a similar reaction that is used to synthesize fluoroalkanes, right? That is your alkyl fluorides. That reaction is your Swarts reaction, that is also there. Okay, next reaction is Friedel-Crafts alkylation reaction. So as simple as it is, what is it? It is a example of electrophilic substitution reaction. That means an electrophile is getting substituted on the ring. This ring is behaving as a nucleophile and this is an electrophilic aromatic substitution reaction. Okay, so again this reaction is happening in presence of a Lewis acid FeCl3 or AlCl3. Okay, what is happening here? This alkyl group gets attached to the ring, right? And we get an alkyl benzene or alkyl substituted aromatic compounds. That is your Friedel-Crafts alkylation. Similarly, if there is an acyl group which is RCOX, this one, in that case this group gets substituted and that is called your Friedel-Crafts acylation reaction. Clear? Okay, we use one more question. We use Lewis acids here. If Lewis acids are not there, then this reaction will not happen because solely this will not be able to do electrophilic aromatic substitution reaction. Okay, next reaction is Gabriel phthalimide synthesis. So it is a important method for preparation of primary amines. Okay, remember it, we synthesize primary amines using that. We take phthalimide, remember the reagent. So firstly we treat phthalimide with potassium hydroxide and convert it into this salt. Okay, convert it into this salt. After the salt is treated with alkyl halide, this R group is important because this is the amine that we'll get. Okay, whatever R group we'll take here, that will be the amine that we will be getting. Okay, and we get N alkyl phthalimide this N-alkyl phthalimide is undergone. After that we do hydrolysis, NaOH aqueous you can take, or H positive H2 something, anything, hydrolysis you do. After hydrolyzing this N-alkyl phthalimide, we will get our primary amine. Okay, so this is a method for synthesis of primary amines, remember that. Okay, we cannot synthesize aromatic amines. Okay, aniline is primary, right? We can only synthesize aliphatic primary amines from this one, aliphatic primary amines from this method. Clear? Next reaction, yes. So the next reaction is Gattermann reaction. Again, we have two reactions of similar name, Gattermann reaction and Gattermann-Coach reaction. Both are different. So in Gattermann reaction, you have a disonium salt. Okay, how do you synthesize it? You have an aniline, right? When you have aniline, you treat that aniline with nitrous acid, right? Or you can say NaNO2 in HCl. And the temperature should be around 0 to 5 degrees Celsius. We get this disonium salt. Sorry, we get this disonium salt. Now this disonium salt, if it is treated with copper and with the copper powder in presence of that halogen acid, we have copper and HCl. Okay, let's say if I want to convert it into chlorobenzene. Okay, so I will use copper in HCl. If I want to convert it into bromobenzene, okay, so what I will use? I'll use copper in HBr. Okay, remember this. Okay, what are we taking? We are taking metal. Copper metal is being used with a halogen acid, Cu in HCl, Cu in HBr. Okay, right? And we get our alkyl benzene. Sorry, we get our aryl halide. We get a aryl halide. What is this? This is aryl halide. That is Gattermann reaction. Okay, now what is Gattermann-Coach reaction? So in Gattermann-Coach reaction, again, in this reaction we synthesize what? Benzaldehyde. So look at this reaction. So in this reaction we synthesized aryl halides, and in the other Gattermann-Coach reaction we synthesized what? Benzaldehyde. The product is totally different. Okay, along with this also, in that we use disonium salt, and in this one we use benzene. So benzene, when treated with carbon monoxide and HCl in presence of AlCl3 and CuCl, this is a catalyst and this is a co-catalyst. Okay, we get benzaldehyde. That is your Gattermann-Coach reaction. Clear? Okay, done. Next, yes. So next one is your, next one is your okay, next reaction. Reimer-Tiemann reaction. So Reimer-Tiemann reaction, again, this reaction is used to synthesize, it is used for incorporating aldehyde group in aromatic phenols. That's where we use it. Okay, so when you treat phenol with chloroform and NaOH, we use this reagent somewhere, right? We use that for Carbylamine reaction. That's how you relate. Okay, so if we treat phenol with chloroform in an alkali, what happens here? We get ortho substituted phenol. Ortho, which group is getting substituted? Formyl group. This aldehyde groups get substituted at ortho position and at para position. Okay, that is your Reimer-Tiemann reaction. Okay, so whenever a phenol is treated with chloroform in NaOH in presence of alkali, what happens here? We get ortho hydroxybenzaldehyde, and aldehyde or a formyl group is substituted at ortho and at para position. Clear? Next reaction. Okay, so next reaction is, one second, something is happening with the screen. Okay, next reaction is Rosenmund reduction. So this is Rosenmund reduction, very simple. Any acid chloride. What do we have? Any acid chloride. When do you treat it with hydrogen in presence of palladium and BaSO4? Hydrogen in presence of palladium, BaSO4 or nickel also. Okay, what happens? Acid chloride will get converted into aldehyde. Acid chloride will get converted into aldehyde. What is happening here? Reduction is happening. Addition of hydrogen means reduction is happening, right? We use this palladium and BaSO4. BaSO4 is majorly used to poison this catalyst so that the reaction will not go further on, because if the reaction did not stop here, what will happen? We will get an alcohol. Okay, but we want till aldehyde only. So again, Rosenmund reduction is used to convert your acid chloride. You can write acid chloride to aldehyde. Acid chloride to aldehydes. And what are the reagents we use? We use hydrogen in presence of palladium and BaSO4. Okay, now next reaction, Sandmeyer reaction. Now remember, you remember Gattermann reaction, right? That was also given by disonium salts. Sandmeyer reaction is also given by disonium salt, but there is a difference. We are getting aryl halides. Again, we are getting aryl halides here also, but the difference is in the reagent. So in the reagent that we used. Okay, so in this case the reagent we use is copper salt. Any copper salt. Let's say if I want to synthesize chlorobenzene, what I'll use? Copper chloride in presence of HCl. If I want to synthesize, one second, CuCl2. Yes, if I want to synthesize bromobenzene, I'll do copper bromide in presence of HBr. Okay, so we use copper salts here. So in this case, we use copper salt. Same reaction, we're getting aryl halides from disonium salt. The previous step is also similar, but we are using copper salt here. We are using copper salt here. Okay, next reaction. Okay, next reaction is our, one second. Okay, next reaction. Stephan reaction. So Stephan reaction is a reaction that is given by nitriles. So any nitrile compound you have, what is this? This is the nitrile group. So if nitrile compound is treated with tin chloride, SnCl2 in HCl, tin chloride in HCl, tin chloride in presence of HCl, it gets converted into what? It gets converted into aldehyde. Simple, right? You don't need to remember this imine and all. It gets converted directly into aldehyde. It gets converted into aldehyde. Okay, now let me see once. Okay, this gets converted directly into aldehydes. Okay, so any nitrile compound you have, that nitrile compound will get converted into aldehydes. That is your Stephan reaction. So again, one of the method for preparing aldehyde. So you can synthesize benzaldehyde also, and you can synthesize aliphatic aldehydes also. Clear? Okay, next reaction. So the next reaction is, what is that reaction? One second. Okay, the screen is getting stuck. I don't know why. Okay, the next reaction is Swarts reaction. So in Swarts reaction, simple, as we have discussed the Finkelstein reaction, there we synthesize iodoalkanes. Okay, in this we synthesize your alkyl fluorides. It is the reaction that is used for synthesis of alkyl fluorides. So there are some other reagents that we can also use. We can use AGF, we can use HGF, we can use COF2 also. We can use COH2F2 also, and we can use Hg2F2 also. Okay, all these reagents can be used to synthesize alkyl fluorides using alkyl chlorides and alkyl bromides. That is your Swarts reaction. What? We synthesize alkyl fluorides using alkyl chlorides or alkyl bromides, and the reagents we use, they are very important, either AGF, either HGF or COF2, right? Hg2F2, all these reagents are being used. Next reaction. So the next reaction is your, which one? The next reaction is, one second, what is the next reaction? Yes, Williamson ether synthesis. So in Williamson ether synthesis, we synthesize what? We synthesize ethers. There is ether written, right? So normally we have an alkoxide ion and an alkyl halide. An alkoxide ion and an alkyl halide, so they both react and we get an ether, right? Simple, very easy. Okay, it's by combining primary alkyl halides. The reaction follows SN2 pathway, very simple. So normally the reaction goes by SN2. So alkoxide ion and your alkyl halide. Your alkyl halide should be primary in nature. Alkyl halide should be primary in nature, or a different mechanism will happen, SN1, and in that case you will not get ether, you will get an alkene. Okay, next reaction. Okay, let's move on to the next reaction. Next is your next reaction is Wolff-Kishner reaction. So Wolff-Kishner reaction is very simple to your that reaction we did in the beginning, Clemmensen reduction, right? So it's similar to Wolff-Kishner, similar to Clemmensen reduction. So in there also you have carbonyl compound. In that case, we treated it with what? So in case of Clemmensen, we treat it with zinc amalgam in HCl. Here we treat it with hydrazine. We treat it with hydrazine, and in presence of, then we do hydrolysis, KOH and ethylene glycol. KOH and ethylene glycol. And what do we get here? What do we get here? Again, same, we will get an alkane. We will get an alkane. Clear? That is your Wolff-Kishner. So again here, aldehyde or ketones are getting converted into alkanes using hydrazine in presence of KOH and ethylene glycol. Okay, next reaction. So the next reaction is Wurtz reaction. So in case of Wurtz reaction, one second, the Wurtz reaction is a coupling reaction similarly, right? So here coupling happens. So you get an alkane normally. Okay, so you have any alkyl halide and you treat it with sodium in presence of dry ether. In presence of dry ether, we get an alkane, right? And sodium NaX, sodium halide. Okay, so very simple reaction. So Wurtz reaction is normally used for your when you want to synthesize same group, aliphatic you have two aliphatic halides, you have two alkyl halides, okay, and from those alkyl halides you want to make an alkane. That's why you use Wurtz reaction. There is a similar reaction. What is that reaction? That is one more reaction we have. One second, Wurtz-Fittig reaction. So Wurtz-Fittig is a different reaction. In here you have two different alkyl halides. In there you should have both same alkyl halides, and here in Wurtz-Fittig you must have both different alkyl halides. One is, as you can see, is an alkyl halide and second is an aryl halide, right? In presence of sodium they react, sodium metal they react, and we get this a substituted aromatic compound. This is alkyl substituted aromatic compound, okay? That is your Wurtz-Fittig. So from Wurtz we get alkanes which are symmetrical alkanes. From Wurtz-Fittig we get a aromatic substituted aromatic compounds, okay? Next reaction. Okay, let's move on to the next reaction. Okay, 1 second. Okay, next reaction. 1 second. HVZ reaction. So what is HVZ reaction? So it is given by carboxylic acid. So carboxylic acid that have alpha hydrogens. Again, same concept. Carboxylic acid having alpha hydrogens. When they are treated with bromine in presence of PbR3 and heated and followed by hydrolysis, we get alpha bromo carboxylic acid, alpha bromo halo acids. That is what you get in the end, alpha halo bromo acids. Now depending on this amount you get, if only one is there, then you get mono substituted, right? And if more than one bromine is there, then obviously all the hydrogens gets replaced, okay? That is your HVZ, Hell-Wohlhard-Zielinski reaction, okay? Next reaction. Next is, 1 second. So the next reaction is Hoffmann-bromamide reaction. So what is Hoffmann-bromamide reaction? So again, this reaction is given by amides. Amides when treated with any halide, okay, any halide you have, X2, Cl2Br2I2, okay, if they are treated with them, Cl2Br2 majorly, in presence of a base, they get converted into primary amines. They get converted into primary amines. So normally whatever amide you have, the amine that is formed, that will have a one carbon lesser than the primary amide that we took, okay. So also it is used for synthesis of primary amines, okay. How do we synthesize it? We treat with chlorine, bromine, and in presence of a base, and we will get one carbon lesser. We get a amine which is one carbon lesser than the primary amide, okay. Next reaction, we're almost towards the end actually, okay. Next is your Kolbe's reaction. So again, Kolbe reaction is one of the method for synthesizing, same reaction that we did earlier. It's similar to that, right? Kolbe reaction, again we have a phenoxide ion. It is treated with, isn't it 1 second. Yeah, so in Kolbe reaction, again phenoxide ion is treated with carbon dioxide in presence of a weak electrolyte. 1 second. Okay, in presence of a weak electrolyte, in Kolbe reaction you have a phenol. Firstly you convert it into phenoxide ion, and that phenoxide ion is treated with carbon dioxide, okay, at 400 Kelvin and 4 to 7 atmospheric pressure. It gets converted into salicylic acid, okay. It gets converted into salicylic acid. A similar reaction we did in the beginning. Tell me the name of that reaction in the comment section, okay. That is your Kolbe reaction. We get salicylic acid. What is salicylic acid? Orthohydroxybenzoic acid, okay. This is one of the primary component that we use to synthesize aspirin. Next, haloform test. Now haloform test is something of a unique test. It is given by compounds, basically aldehydes, ketones or alcohols that have this group. In case of aldehydes and ketones, they should have CH3CO group, and in case of alcohol they should have CH3CHOH group. What happens when you treat them with halogen gas in presence of any alkali? We get PPT, yellow PPT of haloform, okay. Normally if you have iodoform, so iodoform is yellow colored, right? So we get a haloform, PPT of haloform, okay, and we get sodium carboxylate. Okay, whatever you have taken, it gets converted into sodium carboxylate, and this CH3 part will get converted into your haloform, okay. If you have taken chlorine gas, then chloroform. If you have taken iodine gas, then obviously iodoform, okay. That is your haloform test. Next is Hinsberg test. Again, this test is also used to distinguish between primary, secondary and tertiary amines. So primary amines, what is Hinsberg reagent? This is Hinsberg reagent. Benzene sulfonyl chloride. Benzene sulfonyl chloride is Hinsberg reagent. When Hinsberg reagent is treated with primary amines, it gets converted into this species, because primary amines have two hydrogens, right? They have two hydrogens. One hydrogen got replaced by this benzene benzene sulfonyl chloride, and this second hydrogen reacts with this NaOH, right? When you add any alkali to this one, okay, it reacts and we get this water soluble compound. Okay, solution will remain clear after adding the alkaline media, after adding the base. Okay, that is your primary amines. In case of secondary amines, the reaction will happen till here, right? But after that, there is no hydrogen to react with the NaOH. There is no hydrogen, right? So there is no reaction. In this case, you will get a white precipitate, okay, a white or oily layer. Okay, now in case of tertiary amine, only this reaction will not happen, right? This reaction will happen actually, but it's again in case of your tertiary amine, since there is no acidic hydrogen, so again no sulforamide will form and the unreacted amine remains as an insoluble layer. This reaction is actually wrong. I don't think this is the correct one. So just ignore this one. In this case, no reaction will happen. This compound will not get formed. This compound will not get formed. Okay. So again, the amine will remain as it is. The unreacted amine layer will form as an insoluble layer. Okay. Next reaction is Markovnikov rule. What is Markovnikov rule? So reactions we are done with actually. Markovnikov rule is a rule that is used to predict the major product when electrophilic addition is happening. Remember, Markovnikov rule is used when addition is happening, right? So whenever addition is happening with halo acids, right? When you have halo acids and if you are adding them to an unsymmetrical alkene, if you are adding this compound HX to an unsymmetrical alkene, you have two cases. Either peroxide will be present or peroxide will be absent. If peroxide is present, then in that case anti-Markovnikov rule is used. Okay, and if peroxide is absent, absence of peroxide, in that case Markovnikov rule is used. Okay, what is that Markovnikov? What is that anti-Markovnikov? So according to Markovnikov rule, when there is no peroxide there, okay, what happens? This halide, this nucleophile or this halide will get attached to the more substituted carbon. More substituted carbon is the carbon that have more number of alkyl groups. Okay, so here if Markovnikov rule is followed, the halide group will attach to the more substituted carbon. You have two carbons, right? This one and this one. This carbon is more substituted, so your halide will attach to the more substituted carbon, right? Okay, mechanism is also different. Okay, this one proceeds by radical mechanism and this one is a nucleophilic addition. This one is kind of a nucleophilic addition reaction. Okay, now see, when anti-Markovnikov rule is followed, it is totally reversed. So in this case, the halide will get attached to the less substituted carbon. This is the less substituted carbon. That is your Markovnikov rule. Okay, next one. Next is Saytzeff rule. So Saytzeff rule is used for elimination. So when in that case we are adding something to alkene, right? That is your Markovnikov rule. In Saytzeff rule, we are doing the opposite. We have a alcohol sort of compound, any compound we have, right? In that case, we are removing something. We are removing something and we are making alkenes. Okay, we are removing something and we are making alkenes. So it's kind of an opposite reaction, right? So here the rule that is followed is Saytzeff rule. What is Saytzeff rule? So if again during elimination reaction, if we have possibility of forming multiple alkanes, so the alkane which is more substituted, again the alkane that have more number of alkyl groups, that will be your major product. Okay, that is all, I think. Yes, that is all the reactions. If you have any doubts, please mention them in the comments, and yes, all the best for your exam. Don't worry.